started. Let's get to our lecture. So, if you want to see power reducing, you're welcome to take a look at those. We're not going to focus on those. Some of us don't even want to look at it. We can read a book or something. So, write these down. These are your, these are the double angle formulas.
Double angle?
Double angle. These are your double angle formulas. I try to make more space so that you can see them well. So sine 2 theta is equal to 2 times sine theta cosine theta. Cosine 2 theta will be cosine squared theta minus sine squared theta. And then tan 2 theta will give you 2 tan theta over 1 minus tan squared theta.
All I heard was theta. Yeah, theta, theta.
That's a theta, theta.
I think of stomping.
I did that yesterday, actually.
No, it's not good. Where?
Have you guys had the Chipotle ranch?
Yes,
I
those
don't
are my
like
freaking
them.
favorites.
The what?
Sir.
The Chipotle ranch hot Cheetos.
I don't like that.
They're good.
I
don't like
had
them.
a gift exchange and all I asked for was those, and I got like a tower of
You know what I like the jalapeno.
Thank the Lord. They
Jalapenos are good too, but the Chipotle ranch are pretty good too. All right, you guys good?
No.
No.
I like to eat these with cheese. Like the. I just like them. I do it at Circle K.
Huh?
Is Raza?
Razo will be here. Mr. Razo Senior will be here after school
Today.
today.
Mr. Rosso, I asked him if he could help me with this one problem on the test, and he like did it for me, and I was like,
Thanks for the help.
I got it right.
Good.
Yeah, what if I get it wrong? You're just like,
So minus 5 points for. I can change the slide now? All right, let's try this here. So here's our problem. They're telling us that the sine of some angle is 4/5. They're also telling us that this angle exists in quadrant 2, and they want us to find the exact value of the double angle for sine here. Okay? So for starters, you need to draw your theta prime. Okay? So we know that it's in quadrant 2. The sine is 4/5. So that means 4, and then we got a 5 here. Anybody recognize? We used to do that in school all the time.
Yeah.
We had desks that were like,
Really?
covered, yeah. Fun stuff.
My friends started putting them on there, and I was like, you know what, I'm gonna start putting them on there. And then someone messed it up. I only wanted the blue ones. Someone was just like,
And then you can etch your name in there and stuff. Fun stuff. Opposite over hypotenuse. Hypotenusa. No, that's a 5. What is my cosine value here, people?
And then your cosine value is
yeah, it's square root of 3. Over 5. I remember.
wait.
You're half right, okay? I'm just giving you a hard time.
4/5.
What's our cosine value? What's our length here?
Oh.
Huh? -3. Oh. I know what you meant. So that's -3. So there's our triangle.
How'd you get -3?
Because it's a 3, 4, 5 triangle, but x is negative this way.
When did we talk about 3, 4, 5 triangles?
Oh, long time.
Probably one day when you weren't here. Yeah. No, wrong time ago. Back when we were trying to do trigonometry.
Whoa. It was like 4.8.
If you have a triangle whose legs are 3 and 4, the hypotenuse will be 5.
Oh, it's this.
That's why it's called a 3, 4, 5.
Did you record on
No, I didn't. And you just stopped knocking at my door at 10 o'clock at night and then running off.
No.
No, literally, it happened.
Wait, actually?
Yeah.
Hey,
Wait, you know where
Where's
he
the
lives?
toy train and then that? Bro, someone's doing something, I guess. Wait, so did you record it or are you gonna do it?
What?
Did you record our lesson?
No.
I'll just ask Mackenzie.
Yeah, she took pictures for you. All right, so we've got our triangle. We want to find the exact value of our double angle here. So we know that sine 2 theta is equal to 2 sine theta cosine theta. Okay, cool. So let's start plugging some stuff in. What is the sine of theta? Well, we already know it. It's what? 4/5. What is the cosine? Negative 3/5. So we've got 2 times 4 times 3. That's 8 times 3 is what? Negative 24?
Yeah.
So there you go. And we are done.
Okay.
Mr. Munoz, we're gonna say that's math.
That doesn't make any sense. It's like if you take the 2 off the front, it becomes cosine. That doesn't make any sense.
Tell me that one more time. You're looking at the rules.
It says sine 2 of theta equals 2
Okay, so we're trying to do a double angle on this. So for example, if, let's say the theta angle was 15, then you would get 3, and then you'd be looking for the sine of that, of your double angle. You remember how yesterday we figured out we could split them up into a couple of things?
You did not go to T Club anymore.
That's a good idea. Someone in my 6th hour actually saw that over there, Queenie. And like, oh my god.
Something
They're
in your
like-
what?
Your problem that we did yesterday.
No, but in your what?
In my 6th hour.
Which is what?
It's algebra, it's regular 3, not honors 3.
Oh, okay.
And they're like, dude, that's just English. I'm like, no, it's not.
Yeah.
So they were like,
They
what?
probably cried over it.
They were like, where did the numbers go?
Yeah.
No, I was in Boston and they were doing this area. Okay, probably the easiest thing ever. And they're like, I'm confused. This is hard. I looked at them. I said, do not complain about hard. And they're like, why? I was like, do you want to see my homework? Like, no. I was like, exactly. This is not
Exactly. All right, are we good? Are you good?
Yes.
These are just double angles. And if there are questions, you can ask. So here's what we wanted to do, right? Hold on.
Is there any other triangle that should know about?
Oh my god.
Um,
Is that a lot of them?
well, that triangle 3, 4, 5 is called a Pythagorean triple. If you want to know more of them, go Google them. There's just way too many for me to describe to you. But there are many, many Pythagorean triples.
We learned about the, I remember learning about the square root of 3, 1, and then the
Okay, that's your 30, 60, 90.
36.
So you should know your 45, 45, 90, and your 30, 60, 90. Those are the 2 biggest ones that we use all the time. All the time. And then there's some special ones that you should kind of be aware about, like the 3, 4, 5, which is called a Pythagorean triple. There are other Pythagorean triples you can also memorize. What's up? Because technically 2 is 2 over 1, isn't it?
Yeah. Oh yeah.
So I just go 2 times 4 times 3, 1 times 5 times 5.
Okay, and then tangent sine over cosine. And
Yes.
Cosine is opposite over adjacent.
No, cosine is adjacent over hypotenuse.
Alright, I
Cosine
got a,
adjacent over hypotenuse.
Yeah.
I have a really important
Ask.
I did.
on the test.
How's your line doing today?
Are we gonna get given these rules, or do we need to?
You need to know these rules. Memorize them. I'm gonna ask because there are so many rules,
There's so many rules.
and my argument is even in college I was allowed a formula sheet.
It's not opposite over adjacent.
So,
If I can just write
but
them
the other
down.
argument is, okay, you are, but when you take your ACT, SATs, do they give you formula sheets then? No, so you kind of have to know them. You see the argument both ways?
I see
And
it.
our job right now is to prep you for those 2 tests, not necessarily college, even though a lot of people say, yeah, no, we're not. No, don't include it. It'll be there forever.
I'll attempt it.
I like it.
It'll be there forever.
Yeah, you guys work with
Even though I've had some geeky ideas I wanted to do, but what? Do what?
That's fine. That'd be fine. Wait, wait, that's at 2-4.
Were you here when I showed everybody how to do the 45 stuff in your hand? Okay then.
1, 2, 3, 4, 5.
That's good stuff, huh? Alright, moving on. You guys okay with the example? It's just plug and chug, right? Same as before. Alright. These are those are the same thing, aren't they?
Angle? No.
Oh, these are your cosine ones. These are your sine? No? What?
It's what the crap?
Let me look at my notes real quick.
Are there other ways to write it?
Oh, this one's 0.
Look at it.
Oh,
This one's 0. It's always this number.
here's what these are.
It's the Pythagorean.
No, these are also double angles. Obviously, 2 times theta. But they've mathed them so that they all they've done, here, let's do this. Let's go back to here. Let me, shh, they are. Copy, paste. So, that's so. So take a look at. Well, I guess I can't show you, but you know how you can move stuff. Remember when we did Pythagorean triple, the sine square plus cosine square equals 1? And I said, oh, look, cosecant square is equal to 1 minus the other. It's just algebra. That's what they've done here. They've just made them look differently. Okay? And I'm trying to see them for what they are.
Should I write down the cosine ones? Or?
These top ones, yeah, these are the new ones. You already got the bottom ones.
Okay, I was like, what?
And these are still double.
There's no double or power reduced.
How was that?
These are still double angles. See how it's doubled? Theta is doubled. These are all double angles.
No.
Why are there so many cosine?
Because they made them all look into turn to cosine. So here's what they probably did. For example,
Equal the same thing.
yes.
God, this is like.
No, okay, you know what? If this one bugs you, then don't write those down. Here, let me show you this. Shh. Chop, 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 chop. Chop, 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 chop. Look at these that you had, right? Let me take cosine 2 theta. I'm going to show you exactly what they did. I know that from Pythagorean's, what was it? Cosine squared plus sine squared equals 1, right? So if I take this and I move it over, minus sine squared, I can substitute that. I can go 1 minus sine squared minus the sine squared that was already there, right? So that gives me 1 minus 2 sine squared theta, which is one of the formulas, one of the new formulas they gave you, which is right here. See it? All they did was algebra the first 3.
That's it?
That's all they're doing. They're just algebra. Yes.
English, isn't it? We're just too much English.
Tell you what, if that bugs you that much, then make sure you know these first 3, because that's what's important. Okay? Everybody else that wants to have a nicer, a shorter way of seeing things sometimes, you might want these other cosine value ones. Yeah, I would want them. Actually, I have a Bible. If anybody wants to look at it, I've got billions and billions of formulas, statistics. I've got them in trig. I've got them in calc. I've got them in.
Why?
Because you just don't know when you need a good formula. Oh, look at that one. It's for logarithms. I can use that one today.
How did you get happy about this stuff?
Did you write all that?
Yeah.
I don't.
You want to see it?
I want to see it after them.
You can pass it around. And for your diary?
Oh. Mine's
There was
way out
weird
of
when I
date.
actually I required everybody to do one because there was so many formulas.
Yeah, I would never do it.
You should look.
You can't swim. Let's do the same ones though. I can't swim.
Yeah, I'm gonna take a picture of all of it, go home and do it myself just so I have it.
I had a student that actually borrowed it for me,
Uh-huh.
and he Xeroxed everything. And then, like, when he got to college, like a couple months later, he's like, Munoz, you don't know how much this thing has helped me.
Wow.
What if I just take it?
Yeah, it was sitting here for a whole week. If anybody who does want to borrow it, you're welcome to.
The math Bible.
The actual notebook I got at, oh, it's not here no more, Staples.
Nice.
But I'm sure that you can find it at,
We have all this math.
right, at an Office Max. All right, I can move on?
I like how there's like nothing right now on 2 pages, and out of nowhere there's like a circle formula. Where'd it go?
Okay, here we go. Let's have you guys have some fun. Verify this identity, please. Verify this identity, please. Does the what? Oh, I can't. Yeah, that's funny. Does the fun come after?
What am I doing?
Oh, Jackie, welcome back.
I was at 8th grade boys video.
How do I do this?
I did that yesterday.
I have those in there? I think I do. Huh? Double angles are in there and stuff. My half angle, double angles.
It was around my house, we know that, but like, he had to be home by a specific time, and I was going out anyways. So I was like, ah, fuck it, I'll take it.
Verify. Verify that the left side is equal to the right side.
Figure out a sign.
I don't know how to do this technically.
All rules work. They are the building blocks. They are the lemmas. The lemmas. Sorry.
My mind wants to square to cube root. How do you do this?
Split it up, bro. Scooby-Doo, pop, pop. Yeah, boom, 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 boom.
Stop it.
Yeah. Stop. Yeah.
I think if you take
I don't know. Whoever was your sponsor for that, you should do it. Scooby-Doo, pop, pop.
Are we live?
Would you back around? Just take out one of them. No, I have to do that. Because it would make that sign 2 signs squared now.
Well, I see what you're doing. So you factored out. Why don't you just factor out 3 signs?
That would make much more sense. Oh, and then that would make it. And then that would make it.
That would make this
This. It would make it
This
this.
would make this a single one.
Yeah, well, then it would make it cosine 2.
Does anybody have an iPhone charger?
Yeah.
Can I use it, please?
Sir, what are you trying to do to me?
I'm trying to make this muscle flex.
In my life that it doesn't do it.
It's a weak one. It can't lift 50 pounds.
Look it. So you
I
take the other,
know.
you take
I
the
used to
factor
know
out,
all of these
and
by
then it
memory when
becomes
I actually
this.
did
Or,
calculus.
yeah. It becomes
But
no, why would you do
I've done calculus. I did calculus in the summer of 01. I haven't done it in the summer. So when you were reborn, I was learning.
Oh no, I wanted to come out because that's still 2 signs. 1 minus sine squared, that's cosine squared, right? 3 sine. 3 sine of theta. 3 sine theta. 1 minus sine squared. Yeah, sine x squared. Okay, yeah. So then we would equal 3 sine theta times cosine squared theta. Yeah, squared. Cosine squared theta. And then after that we would, because sine squared plus cosine squared equals 1. So if you were to technically take, so you have sine squared theta plus cosine squared theta 1. Just move it over here. The cosine squared theta would equal 1 minus sine squared. 1 minus sine squared. So then after that, we would make it. Yeah, it's cosine squared theta, but then this has to. This is sine 3 of theta. Would I just divide it by sine? No, because. Well, yeah, you could divide it by sine and then get.
Stop.
Stuck.
Wait.
What did you go there?
Stuck. Come help me, please.
Oh, okay, that makes more sense.
Munoz, I'm at a point where I'm stuck. Can you come help, please? So I got here. No, I thought like I could divide by sine.
Because remember, number is different from
The other.
it's different from the exponent, right? So you factored out the sign, which you need to do 1 times squared. That's correct. So let's see if you can multiply this out. It'll give you 3. So 4. Does that make sense?
Yeah.
So you want that to be 4/3 right here. have a double angle in the regular angle.
Well, you take out sine theta and it would become sine 2 theta.
Let me.
Oh. That would have made it so much easier.
Yeah. Hey guys, just a heads up. I see a lot of people trying to attack the right side of that. It's actually going to be easier if you attack the left side of that. By splitting up your triple angle into a double angle and a single angle.
We're talking about double angles.
You have an idea?
So then after that, we would be able to, who knows, after that we'd be able to divide by the sine to both sides, right? And get rid of one.
Yeah, because then now that's
So now we have sine theta times sine 2 theta.
if you subtract, but why would you do that? That's gonna make the other side weird, right? Hold on, let me get mine done too. Sine. Actually, no.
Good job. What?
My first one ever.
I can't do that. Because I would be adding the numbers up front, not the numbers up front. So you have to
Sock is splitting. Isaiah?
So you do the sine of 2 theta plus theta. And now we have one So it would be sine 2 theta cosine theta plus cosine 2 theta sine theta. I think people have tapped already.
I tried, I got stuck. I don't know what to do now.
You really think that I'm happy about this?
So you would take it, you would factor on a sine, right? Math is my favorite.
Okay, here's how you want to do it. I'm taking 3 theta and I'm making it a 2 theta plus theta because 2 thetas plus a theta makes 3 thetas. Because I did that, now I've allowed myself to use one of the formulas that I've had from yesterday, which is alpha plus beta. Remember that? What was the cheer? So now I can do that. So I got sine 2 theta, cosine theta, plus cosine 2 theta, sine theta. Now I also have double angles here that I can use, correct?
Yeah.
What's my formula?
Sine 2 is 2 sine theta cosine.
Becomes 2 sine theta cosine theta.
Yeah.
And then I'm going to color code it. So sine 2 theta is the new formula I gave you. 2 sine theta cosine theta. Cosine theta is just cosine theta, correct? Cosine theta. And then cosine 2 theta. What's my new formula?
Cosine 2 theta. Which one do you want? Just like 4.
They're all like 4. Give me the one that has sine in it. Because remember, I want to get 3 sines. I want everything to be sine, right?
For cosine 2, that's going to be cosine squared theta minus
Cosine squared theta
Minus sine squared theta.
minus sine squared theta.
Yeah.
And that's going to be multiplied by sine theta, correct?
Yeah.
Okay, so here's, you guys okay here? This is complicated.
Honestly, I'm just writing down.
You wrote this?
Wait,
Rar.
Yeah. I color coded it in it.
Where?
Where? Here?
yeah.
Okay, sine 2 theta has a formula, correct? Look at your formulas. Where'd it go? Here it is. See it?
Sine, theta, cosine, theta.
Okay. So yes, you did.
Where'd you pull sine 2 theta though from?
Because you took out sine
Nuno.
theta.
Yes.
Take out theta, subtract out theta.
Years
sine
ago.
2 theta plus sine theta.
Many years ago.
Oh, can I see you? Okay, I'm seeing that.
Where? You okay with me splitting it up?
Yeah.
Okay. So because I split it up, remember yesterday I gave you this formula? No?
Yesterday was
No, I
Wednesday,
don't-
we didn't do anything.
Oh, well,
I wasn't here on Tuesday.
okay, so then you were here for that. So this formula is called I can add, there's a sum difference formula. So if I have the sum, I can break up into two things, kind of like I did here. So 2 theta plus theta gives me 3 theta, right? I split it up into two things. The formula for this goes the sine of the A, it goes, I'll use some blue, okay? So this is defined as sine alpha cosine beta plus cosine alpha sine beta. And that's what I did here. So the sine of the first one, which is 2 theta, cosine of the second, which is theta, plus cosine of the first one, which is 2 theta, and then sine of the second, which is just theta by itself. Is that analytic? Is it killer?
It's, I got it, but it's still
Yeah.
confusing. Like I understand where you got it from.
Should I erase this and start it again?
I'm just gonna do this.
No.
Like, I
Where it says
Everybody's there. Everybody is there. So let me try to color code this a little bit better. You need those formulas. If you don't have the formulas, they're gonna kill you. Is everyone okay with me splitting up into 2 theta theta?
Yeah.
We're okay there?
Yeah.
Have
Not
you-
sure. Yes.
Have you YouTubed all these lessons
Yes.
from this chapter?
All of them.
Okay, I'm gonna go through all of them, write down all the rules. And
Yes. If you don't know the rules, you can't play the game.
okay.
That's why I don't play the game.
I just quoted myself.
Same.
All right. So I've done this. I know that's the formula for that. It would be sine alpha plus beta, correct? Which means I can use sine. Let's do this. I'm just going to write the formula. Sine alpha cosine of beta plus, I'll do green again. No, I'll do blue this time. Cosine alpha, and I ran out of colors, so sine beta. Okay? Now, this is alpha, and this other one would be beta. You guys go with that?
Yeah.
So let's do this. So I've got sine 2 theta.
That's the formula, right? That.
This is the formula right here. I've written it for you. That is the formula that allows me to do sine alpha plus beta. So I've got sine 2 theta. This next part becomes cosine of theta, or whatever the angle is, plus cosine 2 theta, correct? And then finally we have the cosine of theta. So now I've plugged in the angles.
No, you mean the sine of theta.
Thank you. That would have been bad. The sine of theta. Okay?
So theta's just taking up the spots of the alpha.
Alpha and beta.
Okay.
Because we've defined alpha as 2 theta. This is telling me that alpha is 2 theta and beta
Oh,
is
so like
theta.
one of those function things when it's like f of x. is
Yeah,
y.
kind of like that. We're substituting.
Okay.
We're just substituting now. So we're good here, correct?
Somewhat.
Somewhat.
Somewhat is good enough.
Okay. Now, we just did our double angle, didn't we? Sine 2 theta is defined as, someone read it to me again? It was in the last slide. 2 sine cosine, right? So, this red part becomes 2 cosine theta. Wait, was it sine or cosine? I don't think it even matters. Why? Multiplication is?
Oh, wait. It's, wait. What? Oh, I'm so confused now.
2 sine theta cosine theta.
Oh, then that's just two.
Sine theta.
It's just sine. Wait, what?
Which part?
The red part is the red part.
That is equal to that, basically. It's like, you know the Pythagorean identity?
Yeah, why can't you just...
Go ahead. Why can't I just what? Go ahead.
Never mind.
Now the green part is going to stay for now because I can't do much with it. But I've got a double angle for cosine. Double angle for cosine is cosine squared theta minus sine squared theta. So cosine squared theta, what was it? Minus sine squared theta. Okay, so this is getting multiplied by sine theta, right? You guys following my colors?
Yeah.
We're good so far?
Yeah.
All right.
Wait, Gabby has a question.
Yes. Shh. Why didn't I put what?
The red bracket.
Because over here I've introduced a difference, didn't I? Which means I'm going to have to FOIL.
Oh, wait, that's it.
But over here, everything's just multiplied.
So you have to.
See over here, I didn't introduce any subtraction or addition. So I'm okay with just multiplying because 1 times 2 times 3 is the same thing as 3 times 2 times 1. I can multiply in any order I want and I'm good. But not when I subtract
Oh, okay. So
or
not
add.
like this.
Well, definitely not when I
We
subtract.
actually have like something like subtraction. and
Right, because now I have to
has-
use my distributive property,
So
huh?
then that's why you put it in brackets, not like C.
It doesn't matter.
Oh, okay. You just
I can do squiggly lines. I just want to separate them somehow.
This
So,
seems so simple, and I'm really upset that my mind can't wrap itself around.
analytic geometry. It's
Oh,
that's what makes you
I took
thinkers.
the TSAT and my analytical and logical thinking was like,
My brain seriously.
I feel like if you can master this, any math you ever look at would be like, the good old days.
yeah, you're.
Now, I want you to know where I'm going with this. You see the right side is all in sine?
Yes.
Wait.
I'm going to try to turn everything into a sine somehow.
Okay, so we're done.
Do you see that?
Yeah.
So, that means, I'm going to look at this red part. Cosine, that's going to become what? Cosine squared, correct? So here's what I'm going to do with that. 2 sine theta is now going to get multiplied by 1 minus sine squared theta. Do you guys see that from Pythagorean's theorem?
Yeah.
No.
Pythagorean
oh, cosine squared.
Sine squared plus cosine squared equals 1, right?
Yeah.
Right here. Sine squared plus cosine squared equals 1. So if I subtract sine squared to both sides, cosine squared is equal to 1 minus sine squared, which is what I substituted right there.
Got it.
Okay?
Okay.
So, you guys want to just keep attacking left to right or finish my idea?
Finish.
Finish my thought?
Finish with it.
Well, at this point, I'm going to have to
Distribute.
distribute. So I've got 2 sine theta minus 2 sine cube theta. Correct?
Yeah.
Okay.
You're using it as a. You're not doing the 2 by itself, sine by itself. You're doing a full. It's like a whole. Like
I'm distributing it.
It's a whole together.
Yeah.
Okay, so.
Okay.
2 sine.
Oh no.
Wait.
2 sine is and then you get 2 sine cubed.
Okay.
Okay, I get you. I see where you're
You guys see where I went with that?
I got it.
Okay. I'm going to go over to the blue side now, to the right side of this plus. So I've got a plus, I've got a plus. Do you see that this is another cosine squared theta?
Yes.
So that's going to become
1 minus.
1 minus, thank you, my dear, 1 sine squared theta, sine squared theta, and then I've got, oops, black. And then on the outside I've got a sine theta, correct?
Wait, can't you? Isn't that?
You're explaining this so well.
Is that sarcasm or?
No.
Okay.
Wait.
Go ahead.
Cancel them?
No, because they're both negative. So that's going to give me,
Wait. Okay.
So that'll still be a negative, but it'll be sine.
so this will become 1 minus 2 sine squared theta. And then I'm multiplying that by the sign outside, so I've got sine theta.
Why
Yeah,
doesn't
I
it
could've put this,
become,
like,
why
work
doesn't
up,
it
like-
become like sine to the fourth?
Yeah, that's.
Because I'm combining them. Think about it like this. 2x plus 3x is 5x. It's not 5x squared, right?
Okay.
It's only x squared when you multiply it.
5x times 3x is 15x squared. I multiply, correct? Then I add those. But here, if I have 2x's and I add 3x's, now I just have 5x's. Here I'm subtracting, which is the same idea as adding. Correct? I haven't yet. Right, I'm just combining. I'm simplifying like terms. That looks like a T.
Yeah.
So if I have a sine square and another sine square, then I have two sine squares, don't I?
Yeah.
That's what happened right here. We're good? Okay. I'm going to keep this. I can't hold on, don't go!
Can't you wait? And you're trying to make all of these into signs, right?
I have them all signs now, don't I?
Okay, so then
Yeah.
So now I just have to clean it up. Now I just have to clean it up.
Okay. We're good now.
We're in sign mode now, because that's what this whole right side is, all signs. Okay?
Wait, so we're basically right now we're sticking to the right side. We're still on the right side.
Yeah, because I went on the red side as far as I could go, and then because someone said just keep going, finish your thought, and then I went back and tried to clean up the blue side.
Okay.
So right now I'm still on the blue side. I'm going to rewrite the red side.
wait, I have a question.
Yes.
So you know the brackets on the blue, how it's 1 minus 2 sine
Uh-huh.
square, and then why didn't you put the like in the very beginning because it was cosine theta? Why didn't you just put that one there? 'Cause that's an equal.
Yeah, I did right here. But we were only doing the red part to start, remember? And then we came back and we did the blue
No,
part.
see the original, the very top. No, so but see the arrow and underneath the arrow. Go down.
Okay, this is the formula,
No, go down.
and then here I plugged in the angles accordingly.
Yeah, so cosine 2 theta. Is
I could have.
equal- So why,
Yeah.
why did you just?
Because that was my train of thought.
Oh, okay.
If that was yours, if you saw it automatic, you could jump to that.
Okay, so.
There's nothing wrong with that.
So like when you're doing this, like it doesn't matter what.
No,
Oh, okay.
it doesn't. At the end, everything's going to fix itself.
Okay.
If you're doing it correctly, everything will fix itself. So you're correct. You were correct. You could have done it at that point. Okay? So let me, oh, I'm on the blue side. I'm going to have to distribute, right? So that is a positive sine theta.
Yes.
And this will give me a negative 2 sine cubed theta. Let's combine our like terms. We're almost there. So I have 2 sine thetas, and another sine theta gives me how many sine thetas? 3 sine thetas. And then finally I've got 2 sine cubes, and another 2 sine cubes gives me negative 4 sine cube theta. And hallelujah, we're done.
Yay!
Oh, can you put this up like on like math and math lab thing?
What?
Like on the math, like what you said, like we like put the stuff and work.
We haven't done that in a long time.
That's beautiful looking.
Exactly.
I love the colors.
If you had nice my notes have ever
I'm gonna go on my computer and take a screenshot of it.
Um,
Take my screenshot.
Yeah, so.
Okay, just really.
Oh no, the feed was lost.
What?
I'm just kidding.
I was about to say, I was like, dang it, Munoz.
like we just make us run all
Good.
ladies are trying to get really fast.
So yeah, I do. So tell me to slow down. Go ahead.
If we would have done the whole like the.
So from the beginning, you want to change all your cosines into sines. At this point, you would have been fine.
In the end, like, would it have made the right side go like on at a faster like process rather than just going all through that? Do you get what I'm trying to say? I feel like I'm confusing it in a way.
No, I'm just trying to understand your question.
Okay.
If I would have worked with the right side instead,
No, so like if you were to so like the blue side, if
Uh-huh.
you were to put like remember how I brought up, why didn't you put that into that?
why didn't I do it here? Or right here, you mean?
Yeah, like why? So you know the brackets, the 1 minus 2. Remember how I asked you like why
Uh-huh.
did you do that, and you were just like, oh, you did it anyway.
In the red part? Yeah.
Yeah. Okay. So would that have made that like that blue side go at a faster
No.
process? No.
No, because let me show you something real quick. You're saying if I would have plugged in what I said here at that time, technically I kind of did. Follow this cosine 2 theta. See cosine 2 theta now has become what you told me. So I actually did follow that. But I knew what you were saying, and you were doing just fine. I didn't want to confuse you. But if you look at the work I did, cosine 2 theta actually did become the 1 minus 2 theta. Once I was on the blue side, because I kind of worked the red part first, and then I did the blue part. But you know what's funny is, you need to know where you're headed. Because I will tell you one thing. I remember in college, we did a problem like this, and I had 3 pages of me just looping, going in circles, because I kept plugging formulas back into the same formulas. And guess what happens when you take a formula and plug it into the formula?
It
You're canceling it out.
Yeah.
So you're going nowhere. You're just going this nasty, vicious circle. So like I said, understand, I'm trying to get everything to be signed because then it'll clean itself at the end.
What the hell?
What did I do? So all I did was get everything to be into a sign because now I know that when I simplified it, it should all fix itself in the end. Okay? So yeah, this is going to push you to do some thinking here.
Can I just ask you, what would you have done if there was a cosine in the top?
And the cosine over here. Then when I'm doing my red part, I want to make sure that I was in sine mode. And when I was looking at the the blue part, that it ends up being a cosine somehow. But you want that to kind of guide your thinking there, okay? If you have one item, like in this problem, I have one item on the right side, but there's two on the left. I need to think first of a way to split up that one thing to be two things. And in this case, it was the sum difference formula, wasn't it?
Yeah.
Okay? And sometimes you're going to want them to become, you have two things and you want them to become one. Well, that means I got to add my two fractions somehow, get common denominators and all that good stuff. Okay, so if you think about the big picture, it should give you a good way, it should give you some good direction to where you want to go. Let's do it again. Just kidding. These are the ones we don't need to know.
The ones we don't need to know.
Yeah, these are the power reducing.
Why do we need to know?
Because you won't be tested on this. This is not even on our plus standards. When you get to college, you'll probably do some power reducing. If you want to take a snapshot of these power reducing, that's good. Like, for example, if you see something that's squared and you don't like it, you don't want it, see how that turns them into something that doesn't have a square.
That's me.
These are good.
Love it.
Yeah, some people will love these. These are your power reducing. If you don't want to have something squared, you want it to be just a first degree, that's how you do it. There's your formulas for that. Okay? So take a snapshot. There's not much to explain, right? You just have to make them look like that. Okay?
It could possibly also make these work.
Okay, I want to make sure you get your half angles. You guys good?
No.
Okay.
I'm gonna go back.
Wait, where the
Now again, I'm giving you, you're getting a bunch of tools here, right? Think about a mechanic has a bunch of tools. Sometimes one tool is good for the job, sometimes one is better. Okay? I always use the monkey wrench because I can't tell. I can make them all fit, correct? But for example, are you guys done with this? Okay, here's your half angle formulas. For example,
Do you write this one?
yes, you can do that one. For example, I need to do a 15 degree, I need to work with 15 degrees. I know that that's half of 30, correct?
Yes.
So I can use one of these half angle formulas, or I can use the difference. I can go, what did I want to do? Oh, 45 minus 30 also gives me 15, doesn't it?
Yeah.
So I could use a sum difference formula, or I can use this half angle formula. Which one's going to be better for you? That's up to you to choose and decide. All you're getting right now from me is a bunch of tools to put into your tool belt.
I know, I'm trying to put the. All these sin chapters, and you look at the answers.
Greg! Got these formulas now?
What if we don't get to the room?
Don't be that kid that was watching me during class on YouTube. I had that one time. Like when I told them about it, it was like they're like, I asked them a question like, "Hold on, I'm not to that part yet." 30-second delay. Yeah, swear to God, it was so funny.
I was like, wait a minute.
I'm like, why would you have me live?
But they're like, I need to pause you sometimes.
Maybe, but it was funny because like, hold on, I'm not to that part yet. I was gassed. That was hilarious. And then I had a kid that also, when I would come on live, if he was in another class, he'd still watch me. I'm like, okay. Because it'd be funny because I could see how many people were watching, like, live. And I would always have more than one. Because, like, I usually play it, so there's one viewer. But there would always be, like, 2 or 3. I'm like, what's going on? Maybe Lily's watching.
Well, she probably is because.
Hey, where am I?
Actually,
Only one. Just me.
There's people in other math classes that like,
Well.
during my other class, watch my notes.
Like, I was just giving my notes and they read through it. Like, now this makes sense because they have like the formulas.
Oh, your formulas.
They were talking about the formulas. Like,
Still looking for the Krusty Krab formula, though.
I heard the formulas and I was like, yes, yes, it sounds.
What was that?
That was my poor attempt for Mr. Krabs. What's the Krusty Krab formula? You don't watch SpongeBob?
Bad. No, that was just really bad.
So mean.
I was going to audition for his spot.
Cancel.
Start crying.
SpongeBob is an
Teardrop.
I know.
We're not gonna finish. We literally have like.
Actually, we are. We've got one example. Okay, so let's commentate. So they want us to find the exact value for cosine 105. They've given us that the cosine of 210 degrees is negative radical 3 over 2. So what we're trying to find is cosine 210 degrees divided by 2, which is 105, correct?
Yes.
And what is my formula?
It'll be
Cosine half, it's going to be
one
plus
plus-
minus,
plus.
plus minus
Plus minus.
the square root of
1 plus cosine
1 plus cosine.
A. Yeah, cosine.
So this will be radical 3 over 2,
Yeah.
all over 2.
Yeah.
So this becomes, I'm just going to do this right side here. So it's going to be, I mean, I like it that.
Would it be 210 since it's the A?
Why can't
Wait.
No.
use the 105?
Wait, wouldn't it be a minus?
No.
Where's my questions? One at a time. Let's start here, we'll go around.
Why isn't that on a minus?
Why is,
Because it's
oh,
a negative.
because you're right and I'm wrong.
Okay.
You're right and I'm wrong. So even though it's plus on the formula, because that negative radical 3, we should kind of have that, right? Now, cosine 210 divided by 2 is cosine 105, which is what we're after, people.
Why are you using that? Why aren't you using that, like, hold on, I'm watching this. Because it already has the 2 and everything. So why are you using 8?
Because in the formula, I would need the cosine of A,
Okay, I see.
right? And A is the original one that you're trying to have. So this is making me plus minus. This will be 2 minus radical 3 over 2 over 2, right? You guys okay with that?
Wait, no.
Where do you get the 2 from?
Which 2?
The 2 minus over the 2 minus the
This 2?
no, the one above that.
This 2?
Yeah.
Well, what's 1
Oh.
with a denominator of 2?
Oh. Okay. Never mind.
2 over 2, right?
Yeah.
Right?
Yeah.
So we're almost there, so you guys should be good. I'll see what's the homework. All you gotta do is clean that up. You good?
I don't know how to clean that up.
Watch out with that.